What's that? Keelan, you're hot micing a lot, bud. But I know you wanted to get in, so.
No.
What were you saying?
But it's guaranteed that we have a core with at least melted iron due to the magnetic field that we have on Earth, right?
Well, no, I mean that's again that's heavily debated even within your own community. Like I think that was kind of
No, it's
like
not. Who
originally,
debates that?
yeah, that was originally what was said, but that it's been revised and it's no longer a nickel iron metal core.
No, what I'm saying is, whatever
That's not
metal
my
it is,
concern.
we mostly believe it is to be iron. That is what causes the magnetic field, whether it's nickel or iron. But it's something that would cause an like magnetic field, right? You would agree to that?
No. I don't think that the Earth's magnetic field is emanating from the Earth, rather
Why
than
don't you
through
think that?
solar induction. I think that the Earth's magnetic field
It
is
wouldn't.
induced through solar induction.
It wouldn't be that uniform, and it wouldn't remain that consistent shape like that if it was through solar induction.
What do you mean? We got a dynamic system going on. There's what's
Yeah,
consistent about the sun.
Well, no, yeah, but it wouldn't remain that uniform shape on the magnetic field. It would change along with the sun cycle, would it not?
No, not necessarily. Like if
So what
I mean, I don't want to.
constraints
I
do
don't
you
want to.
have
I mean,
that?
this is kind of deviating away from the point I was trying to make. Like, we can get into like what I think the sun is and how magnetism works, and that'll be a long conversation, which I'm more than willing to have with you. But the point I was making was the pressure gradient, right? Like you guys have,
Of the atmosphere?
yeah, the atmosphere. Like you guys got a pressure gradient, and then you've got temperature inversions, which I haven't heard any Glober give a good answer to. But aside from that, the point that I was making is that pressure gradient consistent, or does it invert when dealing with the inner working of the Earth?
It is pretty consistent because all of the Earth below the air is going to have the averaged out center point of always going to the center of the Earth, right? So you're not going to have to deal
Well,
with this weird pulling of being inside the Earth. And yeah,
well,
you're going to
yeah,
have a
you said
uniform pressure gradient of atmosphere.
yeah, you said things are essentially like matter would be floating, and once it got to the center point, and you said essentially it could get locked in, which whatever
Yeah, but if
we
you're
could
above
entertain
Earth,
that, and that's
like
fine. But
the air is
what
going to
does
be
that mean with
above
the
Earth,
pressure?
right? Well, because the air is always going to be above Earth, so it's always going to see the center point of gravity as pointing directly towards the middle of the Earth, right? So it falls down at all points on the sphere. So you're going to have it laying on itself uniformly, and the more denser parts are going to be at the bottom,
So you're
and then it's
saying
going to spread out.
it would be almost an airless environment?
Where? No, in the middle of the Earth? What are you talking about
Yeah.
here?
And I'm focused on the middle of the Earth. That's what the whole
Oh, in the middle of the
conversation is
Earth?
pertaining to. Yeah.
Okay, you're talking about if air was let into it?
Yeah, I'm asking what the air pressure would be at in the middle of the Earth.
It would be at 1 atmosphere, but 1 atmosphere would now be drastically lessened because it is spread through a way bigger uh, amount of surface area now. Because you have to let it through a huge tunnel in the middle of the Earth, so the air pressure is going to lower, but it's going to be uniform throughout the whole thing.
So let me understand this better. So if I were to take a helium balloon to the center of the Earth, which way would it go?
It will stay there.
It would stay there. So you have gas pressure being contained at the center of the Earth, and now you're telling me that it's
Because
one bar.
because it doesn't matter if it's more dense or not now, because gravity doesn't have a direction anymore. It would make sense if gravity had a downward direction. Then yeah, helium balloon would float on the more dense air because the air is being pulled down by gravity just like the balloon is, but so they cancel out and one floats because it has less density. That doesn't matter if
So
you're at the middle of the Earth because you're being tugged on from all directions. So density doesn't matter anymore. There's no buoyance
so
force. There's no
so if
density.
you're at the middle of Earth, and you've got an accumulation of gas, right?
Yeah.
You're saying that it would just equalize. There would be like no expulsion of that gas one way or the other. Like it wouldn't condense down further. You're just saying everything's
It would
just fine
even
and
out.
dandy.
It would even out with the pressure that's on the surface of the Earth.
So you're saying that the gas would transfer from either the center or to the extremity of the Earth, depending on how the pressure buildup was taking
Oh
place?
yeah, I'm
Because you got
saying
high
it
pressure, you
would.
got high temperatures, right?
I'm
At the
saying
center
it
of the
would.
Earth in
Yeah,
your
but I'm
model?
saying it would uniformly spread out and be homogeneous with the rest of the atmosphere. You wouldn't have a concentration of higher pressure still right there, because the middle of the Earth isn't like the highest like density point and where the highest gravity is. When once you go there, you're gonna have one Earth pulling on you from one side, and then the other part of the Earth pulling on you from the other side, and it's gonna even out.
No, I
You
understand
don't
that.
have like
I understand that. Things float in your model, things float in the middle of Earth. I get that. Like the it clown says, they all float down here. Yeah, I understand that, but that's not the question. What I'm saying is you don't have an equilibrium. You have a dynamic system, you have high temperatures, you have gas pressure that's either building up, which I would assume building up continuously. I mean, we see vents, air vents, I forget what they're called, deep in the ocean. I mean, it's just it sounds like there's a lot of contradictions going on in your model, dude. When talking about gravity and the center of your gravity.
okay, okay, but do we agree that gravity exists?
I don't deny the phenomena that when I drop things, things fall, but
Exactly.
I
That's
don't
all
call
that I
that
mean by
gravity.
that.
Yeah,
But that's all that is though.
that's fine. So for the sake of the argument, we can call it gravity because that's what we're accustomed to. But yeah, I don't agree with
And
gravity.
then but then you also agree that we can measure it in certain ways, right? Like we know the speed, we know the acceleration speed of gravity.
9.8 meters per
Nine
second
point eight.
squared.
Yeah. Yeah, exactly,
Okay,
yeah. And
I'm
so
just
that's
looking at
the
something somebody sent me.
we can look at the mass that would cause that type of acceleration and put that into gravity equations. And then we see it matches up with the speed. Then we can try that with other objects as well. Like you could try it on the moon, but now we're granting that the moon is a spherical object in space, which I know not everybody here agrees with. But you could go there, you could jump, and you can measure the gravity there as well, right?
Go to land
That's
in the sky, huh?
mhm.
Killian, didn't you have a question, dude? I don't know if you still have that. I feel like you got overlooked.
Yeah, so from my understanding, the evolution of the spheroid Earth, it evolved through spinning, correct? Didn't it? Like stuff all started coming together based on this spin, and everything kind of formed based on this spin. Isn't that the formation of the spheroid Earth claim?
No, yeah. So it started out as
No, no, yeah,
as a
so?
star.
Whoa, how do you go negative, negative, positive, negative? Go ahead.
What? What do you mean?
You started your sentence with no, no, yeah, no, or was it no, no, yeah, so? I got
Oh yeah.
concerned because I
That
heard
means
negative, negative, positive, and I was like, okay, are
well,
we
that's
right or
because
wrong?
I'm running on a very highly sophisticated algorithm for my explanations. And so basically, in the model, it's not like it just didn't start out spinning, but there was a star, and then that star exploded, so gas went everywhere, and eventually, due to gravity, that gas started clumping up into rocks and then, like into planets, and then the core, most of it assimilated in the core, created another sub-star that we call the sun, and then we're all made out of stardust orbiting this other stardust ball that is giving us heat. And then
Okay,
everything just
so
follows the same gravitational attraction rules, and that's why things orbit around everywhere. And that's why we can predict asteroids and eclipses and
well, okay, no,
seasons and
I wasn't Brother, hold on. I wasn't asking for sky stuff just yet. I was asking for just the formation of the actual like sphere claim.
Okay,
Like
well,
how
yeah, then,
this
yeah, it's an
Earth.
explosion of a star, and it cools down, and it collects into clumps, and yeah, that's
Bet.
how
And the
we.
entire
And it
time
was
this
molten. It's molten at the start, of course, and then it's solidified.
thing is spinning. So as it's
Mm-hmm.
spinning, different little pockets of gas, you say, form different pockets of density, dense. What can I say? Substances collect, and this ball continues to form until it stops forming.
Yeah, until it cools down enough.
Okay, I'll withdraw at that point. Thanks.
All right. Well, yeah, that's pretty much what I agree with.
Well, because I'm taking on what the Russians did, right? Right, they dug to a depth of 7.8 miles or 9 miles, something like that, and they hit this point where they couldn't go any further because I guess the drill bits hit this density where it was literally an impassable barrier. So I'm just curious from your standpoint, what would be on that part, because this has been tested, verified, and true. So
Well,
how does it fit within your claim?
but you also know that it's been tested, verified, and true that the deeper down you go, the hotter it is, right? And especially in that hole that they dug, it was very warm at that bottom. And I don't think they had enough equipment to keep digging. I don't think was it that they hit something impossible? It might have just been a really hard rock or something. Um, there's no reason, like, we know a lot about geology and where certain type of rock would be. Like, we know how to mine gold pretty efficiently. And we definitely know the science on how the planet is formed.
But we
It's
also have
not,
a scale too of how hard things are, right? And so we know like which different material has a different hardness and which drill bit would be required to penetrate that. Like I think diamond
well,
is one of
we
the
do our
known.
best to, we do our best to understand reality as it is. I don't understand why somebody would lie about that.
Well, no,
Huh?
All right, so question being, how would you locally demonstrate this gravity claim?
Well, if you wanted to locally prove the acceleration of it through the Newton equation, you could drop a ball and measure it, see if you get the same acceleration, and then you could derive the mass of the planet out of that.
So you
Uh,
agree that you have to drop the ball, though, in order to observe this force work, correct?
yes, in order to observe gravity, you have to see it in action.
So do you believe in potential versus kinetic energy?
I do believe in potential energy as a good like explanation on a certain thing. Yeah.
Right. So the ball is potential. I pick it up. I impart my energy upon it. It becomes kinetic energy as I
No.
threw it.
Well, yeah, yeah. Right as you drop it, it's kinetic, but right as you hold it up, it's potential.
Well,
Right.
no, I mean, I wanted to invoke a little more oomph in this observation, because, like, to say kinetic energy is just you dropping something. Let's like say I'm going to invoke an energy upon it. I'm going to throw it, right? Use my muscles, articulate my arm, flick my wrist, and let this ball fly. So that
Mhm.
force that I had within me. No, I'm going to walk with this for a bit. Give me a minute. I impart my force upon that with my muscles, articulating my arm, so on and so forth, and that ball, leaves my arm. It achieves a curve, it peaks, right, and I watch this ball dissipate as it literally seeks its new point of rest, so it can become potential energy again. So, from a standpoint of like gravity itself, what are we witnessing? I thought we were just witnessing kinetic versus potential energy.
Sure. I don't see the problem with that.
I had a phone call coming through, dude, while I was in the middle of saying something. My bad, dude. I don't know. Killian, where you at?
Oh, we were just walking out gravity by throwing a ball and trying to figure out if it's kinetic versus potential, or kinetic versus, kinetic and potential energy versus gravity, and how gravity fits into that entire thing.
Well, gravity has potential energy.
Gravity has
you wouldn't have potential
potential
energy without a force.
Can any one of you give an explanation as to what gravity or energy is? Because I mean, it seems kind of futile to debate over potential versus kinetic when I haven't really even heard a concise explanation as to what gravity is. I've heard vague, ambiguous descriptions, like it's the ability to do work, but as we all
Gravity,
know, that's
and
not,
work
that's
is
not
the
what
ability
something
to
is.
use energy. That gets
Yeah.
very cyclic.
What
So
something does isn't what something is. So when I ask what is energy, right? I'd like to hear a explanation.
that's what I'm here for. Yeah, so the thing that defines what energy is that it's a conserved quantity. So like if two billiard balls strike into each other and you look at their speeds before and after the collision, the speeds aren't the same after the collision, but there is something that's the same after the collision. There was something that was transferred from one to the other, and that's energy. Also momentum, another conserved quantity.
Well, I mean, that explains the transmission of energy, right? How it transverses through states. But what we're talking about, what energy is, right? I would say something completely different. I think than that. I would say it's often confused as the dissipation or diminution of energy, but which manifests as impotency of energy. But I think it's something more. I think it's more of a potential. I think energy is a potential
means what
state.
kind of energy you mean, though?
Yeah, I mean, there's a lot of different things that go under the category of energy, and I wouldn't
Yeah, but
say
it's not
that there's
just this one thing.
yeah. What
I would
puts them
say
in
it
that
is.
category is you add them all up, and the total amount of all of them it stays the same. That you can do an accounting and say that okay, there's a total amount of something here that is switching around between objects, between different forms, but the summed up number has remained the same the whole time.
Yeah. Well, that's the thing is. If energy is the ability to do work, then that means that there was energy prior to the work done, which doesn't have a quantifiability to it. So when we're talking about the energy and not the
Man,
action that the energy is doing, then there's nothing to be quantified, and that's partly the problem.
Well, so like a really tangible example of potential energy is the stress in a spring. If you stretch a spring, that puts energy into it, and when you release the spring, you can get energy back out of it. So you can see the conversion happening if you like throw a billiard ball into a spring, and the spring stops the ball. It gets rid of all the ball's motion. The ball loses all that kinetic energy, but now the spring is compressed. And then when the spring decompresses, it shoots all that energy back into the ball, and the ball shoots back with the same speed it had. So like that would be an example of seeing energy turn from one type to another type and then back again. So those are the two categories, like the motion of objects, the kinetic energy, and then any time that it gets stored up in something, to which like the stretched or compressed spring is the sort of most tangible example of that.
Hmm. Well, then how do we get into like 0 point energy per se?
Oh,
Where there's no spring.
Yeah, that's a big and controversial topic, and that's where I would say we've got a big gaping hole at the frontiers of our theories, where you carry out the calculations in modern quantum field theory, and you get to this ridiculous result, which is that the vacuum of space should have not just energy in it, but an infinite amount of energy in it. And then they just say, like, okay, well, we don't know what to do with that, so let's just ignore it and move on. And that's the state of modern physics today.
Right. Yeah.
I feel like it's sort of that's an error in the model, very clearly, from my perspective. But we don't, there isn't a agreed upon fix for it.
Right. So So I don't think we can conclude that energy is necessarily something physical or mechanical in that sense. Um, I mean, we can look at it conventionally in such a way because that's kind of how we work with it. But I don't think we're ever gonna move to a better position in understanding energy when perceiving the outcome of the energy as the energy rather than the unmanifested energy being the actual energy. So like for
Yeah,
example,
no,
like most oftentimes like we kind of conflate um the combustion, right? Like we'll look at the explosion rather than the lumps softball sized lump of plutonium harnessing all of that energy to provide that combustive explosion. But rather than looking at the inverse of that being implosive energy, right? When we start looking at things like sonoluminescence or the Casimir effect, or like I said, 0 point energy, like these are all the things actually working with energy rather than the effects of energy being labeled energy.
yeah, no, everything I was saying is an effect of it. It's a manifestation of it, at kind of a surface level that we can observe. And it's just sort of equating things of like, okay, a ball with a certain amount of mass is going at a certain speed, it crashes into a wall and there's heat generated, so like how much kinetic energy of that ball became how much heat. That gives you an equation of relating one to the other. So, there's something here that we can sort of keep track of in seeing that, consistently, if something with a certain amount of mass moving at a certain speed crashes and explodes and turns all of that into sound and heat, you get a certain predictable amount of sound and heat out of that. But we're just seeing energy, this thing we call energy, turning from like one surface level form to another surface level form. And yeah, you're right. That's like, what is the unmanifested fundamental thing here that is transitioning between all these different embodiments? I wouldn't say that anyone has a clear answer on that.
Well, I mean, have you ever? I mean, it sounds like you've heard something about quantum, at least to a degree, because
Yes.
you mentioned it. But have you ever heard of the other postulation that counters that? I mean,
What are
do
you
you
referring to?
realize that there's only ever been two postulations in the history of science as to what the cosmos is predicated upon? One being
Go for it.
quantum relativity, and the other being the ether. Um, Most people get confused when they hear that term because there's been so many like theories as to what the ether is since like the dawning of time. But
Science does not promote it.
but yeah, I don't think that most people are aware as to what that is or what that's pertaining to. They're only like really given one framework to build off of and consider.
Yeah,
Um,
I don't know what the ether is. I know the word ether, but I
right.
couldn't tell you what people who are trying to build an ether cosmology are doing to describe it, to model it, to think about it. I have no idea how it's conceptualized or what people who believe in it think like it's made of or what it does. So whenever I'm on here with someone who's really in on that, I'd love to chat with them.
Yeah, no, I mean that's definitely one of my fortes that I'm into, and I mean you're gonna get a lot of different answers as to what it is, or what it's not, but um, there's a pretty good channel that I follow called Theoria Apophasis. I don't know if doesn't really roll off the tongue that great, but if you get a chance to check that out on YouTube, that guy really talks about it a lot and
Okay.
breaks it down. But essentially, it's talking about these two field states being the magnetic field and the dielectric field simultaneously inducing one another
Hmm.
to create essentially electricity, light, and magnetism.
Yeah.
So the loss of the dielectric field breeds the magnetic field, and the loss of the magnetic field breeds the dielectric field. So essentially, you got these two field geometries. One being the magnetic toroidal field, which is analogous to my avatar, and then the other being the inverse of that, which is the hyperboloid, which is like the hourglass geometry, and how they're synonymously connected and inseparable. And it pretty much gets a lot deeper than that, but it accounts for essentially all field phenomena. Like could be explained pretty simply with ether field theory. So it's something worthy looking into. They actually have like a grand unified theory, whereas the mainstream model is subdividing fields against natural order. So like they think they've got gravity over here and a magnetic field over there, a light field over here, electric field over there. So they're not quite unified. They're like countering that, but
The
while
ether doesn't
simultaneously touting
unify
that they're
well
working
with
towards it.
gravity.
What's that?
The ether doesn't unify well with gravity, though.
Well, the ether explains gravity pretty succinctly.
But it doesn't predict the value that we predict in the other model. Like it doesn't. You don't have a. It's like just a geometrical model, pretty much.
No, I don't. I wouldn't say that so much. I would say it is predictable to a large degree. There's, I don't think we're gonna wrap it up in a short conversation. So it might be something that you'd have to spend some time looking into yourself before just making, ad hoc assumptions that it's not worthy of, or dismissible. But it's another way to kind of view things. So that's not
I
materialistic.
understand.
Yeah, like basically everything today is based on particle interaction, right? It's essentially the quantum cult of bumping particles, and this is like antithetical to that. So
Yes, but actually, the definition of a particle is not like a little hard ball of something. The definition of a particle in quantum field theory is a wave pulse within a field. It's a small kind of propagating, waveform of disturbance moving
right,
through a field.
right. Well, that's precisely what it is. It's the intersection of the two fields converging that's being ideated as a particle.
Yeah.
When in fact it's really not a particle. But like when you talk to a quantum physicist, they'll tell you that a particle is separate from a field, and every particle has a field, and the field precedes the particle. So they're clearly making a distinction between the two instead of realizing that it's a manifestation of the
It's
one
just an
field itself.
excitation in the field. Yeah.
Right. Yeah. Exactly. It's the peak or the trough of the wave or the
Yeah.
crest or what
It's
have
just
you.
going by and
But
vibrates.
yeah, but they kind of perceive it as particle interaction. So like if you were to ask them on a deeper level what magnetism is, like what's responsible for the attractive properties of magnetism, and they'll tell you it's the exchange and emission of virtual particles.
Yeah. But yeah. So you can definitely analyze it that way. But what those virtual particles still are representing is those peaks, in little wave packets moving through the magnetic field. So they're still not being conceptualized as in sort of like material solid terms.
Oh no, they
But
are, certainly are. And they even break down the particle into subatomic particles and have names for those quarks or what have yous, and what on so on and so forth.
No,
So
but
no,
all
they
matter
are
has
purely
quarks.
physical. Yeah, they're purely attributing physicality to the particle and
Yeah, but that
separating the
doesn't mean they
field.
don't think it's in a waveform, though.
No, I'm not saying that they don't ascribe a wave to each particle in the sense of a field. Like I've already addressed that. But again, a field is not a particle, and a field is not comprised of a particle. So when you're talking in terms of fields versus particles, there's a distinct separation from the atomistic perception of it. I mean, if you fail to realize that, I don't know what to tell you, but that's their model. Not that I agree with it, but that's their model.
I think we just define certain wavelengths as a particle.
Yeah, so like a photon is referred to as being a particle, but it's also
Good.
a pulse in the electromagnetic field, and that's what they
Right,
talk
and
about being exchanged between the magnets.
right, but
Uh,
they haven't defined a field. They haven't defined magnetism. So just meshing words together, electromagnetic field. I mean, is great. I don't disagree with it, but again, no branch of science has addressed these things, such as energy fields, magnetism, or
They
even
have.
electricity
We
for
even
that matter.
create oscillating electric fields to our needs to send out electromagnetic waves in terms of Wi-Fi and do ones and zeros and packets in
What's
there. I
It's
mean,
funny when you say we, as if
as
the
in
quantum
our
relativist
species,
created
you
that.
know.
Well, I know. I mean, we can throw everything in the same basket and slap a label on it, but the problem is that the guys that created our entire electrical grid today weren't weren't fancy to an electron or particles. They understood something completely different, and they talked about this thing that I'm telling you about, this dielectric field and the magnetic field inducing one another to create electricity. Such as J.J. Thomson, Oliver Heaviside, James Clerk Maxwell, Nikola Tesla, Charles Proteus Steinmetz. I mean, the list goes on. There's a long list of these guys that pioneered what we have today, and they weren't fancy to an electron particle.
so when you talked about the sort of what's the precise definition of something like the magnetic field. There's a great thing you can do where if you just take a magnet, I posted a picture of it, and sprinkle down iron powder around the magnet. The iron powder forms these
Yeah,
streaks
I'm
around the
aware of the
magnet.
iron
Yeah,
filings creating
yeah,
the highlighting what the field's doing.
yeah. So the
J.J.
field
Thomson,
is very
was it J.J.
implicitly
Thomson?
defined as just whatever force is there in space that's making the powder form into the streaks.
Yeah, that's where they got the lines of force that they came up with, which was a false concept.
I mean, one of the sort of difficult and frustrating things about all this is nothing is defined in terms of what it is, but instead in terms of what it does. Like the definition of like, what do you mean by magnetic field? Well, it's the iron powder is forced into these streaks, and the magnetic field is the strength of that force. It's not even, there's not even
Not
sort of an
quite.
answer as to the what, just the what it does.
Yeah, not quite. Yeah, because I mean there is no magnetism at the center of any magnet. I mean you can clearly see that with any Gauss meter. The what you call magnetism resides at the plane of inertia, which is 45 degrees parallel to the face of the magnet.
I mean, if you crack a magnet open, you get two smaller magnets.
And
So,
if you crack it down all the way to the atom, you can't separate it.
What does that mean?
individual
What
atoms
does
are
that
still
even mean,
magnetic.
Dieslow? I mean, you're saying things that really don't mean anything as far, I mean, talking about the magnetic field and the plane of inertia. And like you said, you can break a magnet in half. You've got two magnets. So what does that mean?
I mean, if you can't follow the conversation, Liflin, I don't know what to tell you, but he talked about the strength of a magnet, right? And highlighting that with the iron filings. And
Yeah.
I'm simply making a distinct point here that there is no magnetism at the center of any magnet. So what you call magnetism,
What does that mean?
yeah, well, I'm trying to explain that. I don't know, you just feel the incessant need to interrupt me, I guess. But yeah, that means what you're calling magnetism, right? Is something that is not actually at the face of what you're calling the attractive or repulsive side of a magnet.
I just meant if you want to see if there's magnetism in the center of the magnet, you could saw the magnet in half, and then the two halves are still magnets. So
Right, you can't separate them. Yeah.
yeah, we can't isolate the north from the south, and it goes all the way
Nope.
down to the individual atoms. Even the individual atoms are magnetic.
Correct. And in fact, before you magnetize a piece of metal, prior to after, there's no anatomic difference because it's not a quantitative thing; it's a qualitative thing.
Hmm?
Yep. But And
so-
and also another fun fact is that the stronger the magnetic field, or sorry, the stronger the magnet, the smaller the magnetic field. It's really counterintuitive, but it's pretty interesting that it works that way. And in fact, if you were to measure the strength of a magnet with a Gauss meter, it falls off, roughly about 2 feet. But
Yeah.
you could still see the effects up to 100 feet, which is kind of bizarre. Like if you were to take a CRT tube set television, old school tube set television, you could see the field array across that tube set at like 100 feet plus, which science can't explain.
Well, not sure exactly what experiment you're doing there.
You could do it yourself. Yeah, I mean, you can get an old school tube set television from like a thrift store for like $20, and just pick up like a neodymium N45 Gauss magnet. And you could do that yourself. It's a really simple thing.
But does science say that the magnetic field stops at some point?
It just diminishes
says that the
with
magnetic
distance.
field. Science said that the magnetic field diminishes at a distance, but never quite hits zero. In fact, they actually say that it stretches off into infinity and beyond to the furthest reaches of the galaxy.
So so it's no wonder that you could maybe see it in a cathode ray tube at some
Not
distance away.
necessarily. Not necessarily, because the amount of energy required to affect that tube set following the inverse square law should not affect that tube set at 100 feet away using an N45 Gauss magnet.
But the magnetic field doesn't fall off at the inverse square law. It falls off faster.
That's what you say. But again, I like I said, I could see the effects of it at a longer distance than what's measurable.
Well, if you can see the effect, surely we can measure it.
Well, surely infinity and beyond exist too. But yeah, again, left lane, if you're following, magnetism is a quantitative rather than a qualitative.
Well, all I know is we could use it. We utilize it. We've got electromagnets. They load steel on my truck using electromagnets. They pick up
I got
fresh
'em on my
cars
fridge
with it.
holding up stickers.
They're fun to play with. You can stick notes to the refrigerator. What else do we need to know?
There's a lot. Why don't you try giving an explanation as to what it is, rather than saying the
I don't
interaction
care.
of virtual, rather
I don't
than
care what
saying
it
the
is.
interaction of virtual particles.
I use it.
So another
Yeah.
thing we can do, like the iron powder around the magnet, is you could put iron powder around a wire, and then when you turn on current in the wire, it causes the same streaks in the powder. So like, I posted a picture of a
I've
wire.
seen that.
Yeah.
I've seen art done like that. Have you ever seen a supercell or a ferrocell?
Mm.
You know what that is?
A supercell? No, not sure.
So it's essentially two optical lenses sandwiched together between a small amount of ferrosurfactant fluid, like maybe a couple drops, right? Which is like less than a micron thick of a gap between the two optical lenses. And when you put a magnet in line with that and a little bit of light, you get the holography of the magnetic field.
Cool. Nice.
Yeah, it's really neat. If you've never seen that, I suggest taking a look at that. There's also a magnetic viewing sheet, like it's like a film sheet you can get for like really cheap, but it's nothing in comparison to a supercell.
I love
But
watching
you could
videos
actually
of levitation.
you could actually
yeah.
Oh, good.
No, just saying the videos of like levitation with like the super strong, super cold magnets.
Oh, quantum locking. Yeah, that shit's pretty cool. Yeah, there's a lot of going on with magnetism, dude. We haven't even scratched the surface when it comes to magnetism. So if you're left lane to act like there's nothing left to see, dude, it's pretty funny.
No. I'm not acting like that. I want to know what good is it. You know me. If I can't use what you're talking about, I have no use for it. So that's kind of my position. What good is all of this information that you're laying out?
Electricity generation.
So Tesla said that his greatest invention or discovery wasn't that of the AC generator, rather than the discovery of rotational magnetic fields.
Mhm.
And he said that the understanding of that would surpass science itself and has countless ramifications to it, like multifaceted applicability, like beyond your wildest perception. It's essentially it's a point source. A magnet is a point source tool, and like if you think about our some of our most sophisticated devices, like can't even work without them. So I mean, it's highly useful, highly applicable. In fact, it's inseparable and intrinsic and extrinsic from all phenomena. So yeah, understanding magnetism should be the pinnacle at the forefront of science at this point, but it's not.
Also, I want to just clarify for anyone curious, because this gets like missaid so much by so many scientific presenters. The whole business with the virtual particles is not an explanation as to what the magnetic field is made of. It's not actually even the case that the model is saying that the field is made of these virtual particles. The virtual particles are just pulses moving through the field. So it still doesn't even address the question of what the field is. It's just saying that the way energy gets transmitted through the field is happening in terms of these little bursts, these little pulses, that if you could see two magnets repelling each other under like a really intense microscope, it's not a smooth repulsion, but it's, it's stuttered. It's happening in little individual kicks of pulses traveling through the field. So they're kicking off the question of what the field itself is made of.
Yeah, I
Right.
think a really good word for that is oscillations. They're starting to measure.
in little oscillations through the field.
Yeah. So I think certain magnets, not even the strong magnets. I've seen this just made me think of it, but I'll try to find the video. But it's oscillations of 9 billion, like some odd hundreds millions. I mean, it's pretty amazing that all these things are happening way too fast for us to notice. We just see the force that it produces, right? Or the effect that the force produces.
Yeah, I mean, we're always seeing effects of things that we're left to try to fill in a story of what we didn't see.
There was something you said earlier, Dieslow, that is intriguing, that maybe is worth touching on. That maybe Tesla didn't know what an electron was, or didn't have a concept of an electron, but today we do. And so, I mean, is that in any way detrimental to say that he didn't know what an electron was?
In terms of you said Tesla.
Yes.
Tesla? Nah, yeah. Tesla gave some thought on the matter. In his interview in 1928 on the subject, he said that he disagrees with the accepted atomic theory of matter and doesn't believe in the existence of the electron as pictured by science. Quote, to account for its apparently small mass, science conceives of the electron as a hollow sphere, a sort of bubble. Such a bubble could exist in a medium as a gas or liquid because its internal pressure is not altered by deformation. But if suppose the internal pressure of the electron is due to the repulsion of the electric mass, the slightest conceivable deformation must result in the destruction of the bubble. Just to mention another improbability. And that was from a famous prophet of science, Looks into the Future by Popular Science Monthly. Here's another quote. My ideas regarding the electron are at variance with those generally entertained. I hold that it is a relatively large entity carrying a surface charge and is not an elementary unit particle. When the electron leaves the electrode of high potential in a vacuum, it carries an electrostatic charge many times greater than that normal. End quote. I can go on, but point is he didn't agree with the electron. Neither did Steinmetz, and in fact, J.J. Thomson, upon his discovery of the electron, referred to it as a a corpuscle of dielectric capacitance. He didn't refer to it as an electron until he was persuaded with a Nobel Prize award. So now, the electron or electricity, should I say, is a dual head hydra, essentially consisting of dielectric and magnetic induction. Like I said, that's why Charles Proteus Steinmetz came up with the equation phi times psi equals Q Planck of electrification. And if you were to overlay an electric field with a magnetic field, you'll see that they're exactly the same. They're synonymously related, which should tell you that electricity isn't a thing in that of itself. And you can never separate the magnetic field from the electric field, but you can separate the magnetic field from the electric field. So this should tell you that one precedes the other.
So is it something that is how would I say is it always symmetric and simultaneous, like, with its own makeup? I guess you would say it would be a sentient creation in a way.
I don't like how that word sentience gets thrown around. To me, I
Well, that's why I'm asking.
perceive
Just asking.
sentience as like conscious awareness. I don't really apply sentience to innate material or matter.
Right, but the underlying force that holds it together and possibly even creates it, like or created it, or I don't know the right exact words, but you see where I'm going with it, right? Like something is there holding it together. I wouldn't see it just as a force, but as a created force, right? And I say that kind of, I'll give you an example. Like, if you have two magnets and you have them far enough apart where they're not, reacting or with each other, but then you bring them close enough together at very certain angles, and then all of a sudden this force knows exactly how to repel it in the opposite angle, right? To create whatever angle its forces there are pushing against each other, right? But I don't know. It's always been one of those things where you're right. You can't separate it except in a certain order, or with certain dielectric, interference. So it makes me think like, yeah, this force is always sentient around us, but then it won't give you what you expect, or it won't give you the opposite reaction against itself until you get them close enough. So it's not so in that sense, it's got to be somehow aware. I wouldn't even say conscious, but aware, right, of itself. But yeah, I don't know. It's so cool to me to sit and think about. But I don't know. I don't think I asked the question. I'm just rambling. But yeah. So what's on the mind of the people today? What's the subject that's someone has a burning desire to talk about today?